Hey guys, welcome back. Chapter 5, Section 4, Sum and Difference Identities for Sine and Tangent. Let's find the sum and difference identities for sine first, and then we'll move to tangent next. All right, first, I want you to consider what is sine of a plus b. This will be the sum identity for sine, all right, cool. By earlier studies, we know that cofunction values of complementary angles are equal. So we know that sine of a plus b will be equal to cosine of the complement, right? The complement of a plus b. Sine and cosine are cofunctions, and so what I must write here is the complement of a plus b, which is 90 degrees minus a plus b. This is a cofunction identity, all right, cofunction identity. Sine and cosine are cofunctions, and a plus b and 90 degrees minus a plus b are complements, right? All of this is the complement of a plus b. All right, cool. So this is equal to, if we can do a little bit of regrouping here, this will be 90 degrees minus a plus b, or minus, right? Minus b. Good. Now, by the difference identity for cosine, we know this is cosine of 90 degrees minus a times cosine of b. Now watch this, plus, right? Sine of 90 degrees minus a times sine of b. Let's see if I can fit it in here. Let's move that over a little bit. Let me just move this screen over just a little bit here. Sine of b is what I need to write. Sine of b. All right, cool. Now notice that this 90 degrees minus a, cosine of 90 degrees minus a, is the same thing as saying sine of a, right? This is the complement of a, so then this must be the same thing as, by a cofunction identity, sine of a. This is cosine of b, plus, now here, this is the same thing as cosine of a by a cofunction identity, right? The reason here, just want to make sure you're clear, sine and cosine are cofunctions, and these two arguments are complements of each other, okay? And then bring down sine of b. All right, this is the sum identity for sine, okay? So we have sine of a plus b. Let's see if I can squeeze this in here. Sine of a plus b is equal to sine of a cosine of b plus cosine of a times sine of b. All right, I want you to notice the pattern. Sine and cosine are together. Sine and cosine. It's sine of a, then cosine of b. And notice that the sign is the same sign, right? Plus and plus. And then cosine of a, sine of b. I wonder if you can follow the pattern to get us sine of a minus b. Let's see if I could. Sine of a minus b. Well, if you follow the pattern, it'll be sine of a, then cosine of b, keep the same sign, and then cosine of a, sine b. Now this is the difference identity for sine. All right, cool. Okay, I've written on top what we derived so far. Now what I want us to do is derive the sum identity for tangent. Now, by a quotient identity, we know that tangent of a plus b is the same as sine of a plus b, over cosine of A plus B. All right, by a quotient identity. Now, we know how the numerator expands. We know how the denominator expands because we proved both already. So then we have sine of A in the numerator, cosine of B, plus cosine of A, sine of B. That's the numerator. Okay? Over the denominator, which is cosine of A, cosine of B, minus sine of A, sine of B. Cool. We derived both of those already. Now, this, unfortunately, right here, this looks like a 13, and it's not. Let me erase that and just write that a little bit nicer for you. Make it look like a B. Okay, that's much better. All right. Now, what I want you to do is to multiply the numerator and denominator by the same thing. Now, when you multiply the numerator and denominator by the same expression, you're multiplying by 1, and therefore not changing the original value of the expression. So this is what I want you to multiply the numerator and denominator by. 1 over cosine A times cosine of B. All right? Multiply the numerator, getting a little sloppy there. Multiply the numerator by that. Good. And the denominator by that as well. Okay? Like that. Okay? All right, cool. Now, let's keep working. So what you're going to have is sine of A times cosine of B. Now, when you multiply this first expression, sine of A cosine B, by 1 over cosine of A cosine B, that gives you sine of A times cosine of B over cosine A cosine B. So we have cosine A cosine B. Cool. Let's keep going. Plus cosine A cosine B. Or cosine A, excuse me, sine B. That's this term right here that I just wrote. Right here. But this term here is also being multiplied by 1 over cosine A cosine B. That's the same thing as saying this term is being divided by cosine A cosine B. Let me show you that. All right, there's the numerator. Now that over, now we have cosine A cosine B. That's this term right here, being divided by cosine A cosine B. Trying to write as neatly as possible so that you can follow. Excuse me. Minus sine A, sine B. And that's also being divided, like everybody else, by cosine A cosine B. All right, very good. Now, I want you to notice what you have here. Look here. Let's see. Cosine B over cosine B divides out. Sine of A over cosine of A is the same thing as tangent of A. Over here, cosine A over cosine A divides out. And sine of B over cosine B is tangent of B. Over here, cosine of A over cosine A divides out. Cosine of B and cosine of B divides out. So this is just the number 1. And let's see. Over here, you have sine of A over cosine of A. That's tangent of A. And then you also have sine of B over cosine B. That's tangent B. So let me see if I can move this up here and show you that you get tangent A plus tangent of B all over 1 minus tangent A times tangent of B. There. This is the sum identity for tangent. the sum identity for tangent. Here, let me rewrite it for us. I'm going to rewrite it. Tangent, this is what you and I just figured out. The tangent of A plus B is equivalent to tangent of A plus tangent of B. All that over 1 minus tangent of A, tangent of B, like that. A little sloppy right here. Let me fix that for you. So this is tangent of A, tangent B. If you notice the pattern, I want you to see if you can maybe even pause the video and figure out what tangent of A minus B is. What is this equal to? All right, I hope you pause the video. If you follow the pattern, then it'll be tangent of A minus tangent of B in the numerator over 1 plus tangent of A times tangent of B in the denominator. All right, cool, guys. This is the sum and the difference identity for tangent. All right, guys, up top I have our sum and difference identities for sine. And this is the first example. They want us to find the value of each of the following expressions. So here's the first one. Sine of negative 15 degrees. Okay. You know as well as I do that 15 degrees or negative 15 degrees is not one of our special angles. And so we're going to use an identity to rewrite this. All right, so I'm going to say that sine of negative 15 degrees is equivalent to, I'm going to say 30 degrees minus 45 degrees. That's the same thing as sine of negative 15 degrees. You can see I rewrote this as a difference, so I'm going to follow this pattern up here. Sine of A minus B is equal to sine of A cosine B minus cosine of A sine of B. And of course, I'm referring to 30 degrees as A and 45 degrees as B. All right, everybody? So then when I apply the identity, I get sine of 30 degrees cosine of 45 degrees minus cosine of 30 degrees sine of 45 degrees. Cool, which is, let's see, this is equal to 1/2 times root 2 over 2 minus root 3 over 2 times root 2 over 2, which gives me a final answer of root 2 minus root 6 and everybody over 4. All right, awesome. Let's look at the next part. So example 1, I guess this is part A. Let's look at example 1, part B. All right? All right, everybody. I have very sloppily written, I have the sum and difference identities for tangent. All right? So that we can reference them for this next part. They want us to find tangent of 13 pi over 12. All right, now we all know that 13 pi over 12 is not one of our special angles, so we're going to rewrite this as a sum. Okay? Tangent of 13 pi over 12 is equivalent to tangent of, let's see, what if I rewrote it as, what about this? 9 pi over 12 plus 4 pi over 12. That would be a tangent of 13 pi over 12, wouldn't it? So then this would be equal to tangent of pi, let's see, this would be, simplify each one of these fractions, 3 pi over 4 plus pi over 3. Okay? So now what I'm going to do is use my sum identity for tangent. That is, I'm going to follow this pattern up here, right? Where when I apply it, this is my A, 3 pi over 4 is my A, right? and then this is my b. All right, so here we go. Let's apply the identity. So then this is equal to tangent of 3 pi over 4 plus tangent of pi over 3 over 1 minus that, the product of those two. So tangent of 3 pi over 4 times tangent of pi over 3. Okay? This right here, folks, this says 3 pi over 4. All right, cool. Let me move the screen up a little bit here. All right, maybe about there. Okay, so then this is equal to tangent of 3 pi over 4 is equal to -1 plus tangent of pi over 3 is root 3 over 1 minus that product. Tangent of 3 pi over 4 is -1 and tangent of pi over 3 is root 3. Okay, so then this is equal to, I'm going to rewrite it as root 3 minus 1. And I'm going to write this as root 3 plus 1. Just because addition is commutative. Okay? All right, cool. Now, unfortunately, we're not done because we should try to rationalize our expression. Let me move this over to the left, okay? So here, in order to rationalize, you want to multiply the numerator and denominator by the conjugate of the denominator. The conjugate of the denominator is root 3 minus 1. Root 3 minus 1 just happens to be the conjugate of the denominator. Let me remind you about conjugate. The conjugate of root 3 plus 1 is basically just changing the operation from addition to subtraction. That's the only difference, okay? Root 3 plus 1, then the conjugate is root 3 minus 1. All right? So let us multiply. And when you FOIL out the denominator, you're just going to get root 3 times root 3, which is just 3. And then the outer and inner products will cancel. And then the 1 times -1 is just -1. Okay? The numerator, you're going to get root 3 times root 3, which is 3. You're going to get minus 2 root 3. I'm assuming you are really comfortable with, some people call it foiling or just distributing, right? That's what I'm doing here. All right, I'm distributing. I'm doing this, folks. I don't mind showing this. This times that, and then this times that, and then this times that, and then that times that. That's what I mean by foiling. I did that in both the numerator and denominator. I'm ready to combine like terms. In my numerator, I have 4 minus 2 root 3, and in the denominator, I have 2. When I divide everybody by 2, then I get 2 minus root 3, which is my final answer. This is tangent of 13 pi over 12. Okay, guys, this is the last part of example 1. Again, please reference your sum and difference identities for tangent up here towards the top of the screen. And then this is the expression that they've given us. They want to know the value of this expression. Okay. Does this whole expression look similar to either one of these on the right side? You should see that it's similar to this right here. Tangent of A minus tangent of B. Notice tangent of 100 degrees minus tangent of 70 degrees. And then 1 plus tangent A, tangent B. You got 1 plus tangent 100, tangent 70. Right? So this expression definitely follows this pattern on the right, which means we can rewrite it like the left. Okay? So here, I really want you to consider that 100 degrees is A and 70 degrees is B, right? This is A and that's B, right? So then when you apply the identity, we can rewrite it, we can condense it as tangent of A minus B, or 100 degrees minus 70 degrees, which is just tangent of 30 degrees, which is just root 3 over 3. Cool. That's it. Cool, let's move on to example 2. All right, example 2 says, write each function as an expression involving functions of theta alone. There's going to be a few here. All right, so here it is. Here's the first one in this set. So sine of 120 degrees plus theta. Okay, now folks, we know that this is a sum, right? So by the sum, I don't know if you need a peek in your notes. If you do, that's fine. But use the sum identity to expand this. All right, the sum identity for sine is sine of 120 degrees cosine of theta plus cosine of 120 degrees sine of theta. Okay, and then we can simplify. Sine of 120 degrees, if you prefer radians, that's fine. Sine of 120 degrees is the same thing as sine of 2 pi over 3, and that is going to be positive root 3 over 2 times cosine theta plus cosine of 120 degrees is going to be negative 1/2 times sine of theta. Okay, so then you're going to get, let's see, root 3 cosine theta minus sine theta, and everything is over 2. All right? Good, cool. That's all they wanted you to do. Now everything is is written as a function of theta alone. See, it's not 120 degrees plus theta as the argument anymore. Every single argument is just theta. Cool, let's look at another one like this. All right. They've given us tangent of theta plus 3 pi. All right, let's go for it. This is the sum identity for tangent. If you need to look at that again, that's fine. But it is going to say to expand this as tangent of theta plus tangent of 3 pi. Hey, when they say 3 pi, we all know that 3 pi is coterminal with 1 pi. 1 minus tangent theta times, oops, I forgot theta, times tangent of 3 pi. All right, cool. So this is tangent theta. Now, tangent of 3 pi is equivalent to tangent of 1 pi, which is just 0, over 1 minus tangent of theta times 0. 0 is tangent of 3 pi. All right, cool. We have tangent of theta over just 1. So then this is the same thing as just tangent of theta. Cool. Let's look at one last one, okay, everybody? All right, they've given us sine of theta minus 270 degrees. We're going to expand this using the difference identity for sine. It would be really great, you guys, if you pause this video and reference the difference identity for sine and work on expanding this. I'll give you a minute to do that. All right, if you've taken the time to expand this on your own, you should get sine of theta times cosine of 270 degrees minus cosine of theta sine of 270 degrees. Okay. If you prefer radians like I do, 270 degrees is the same thing as 3 pi over 2. So this is sine of theta. Cosine of 270 degrees is 0 minus cosine of theta. And then sine of 270 degrees is negative 1. So then this is 0 plus cosine theta, which is just cosine of theta. Awesome. Good job, you guys. Let's go to example number 3. All right, guys, here's example 3. It's kind of lengthy, so follow along as best as you can here. Suppose that A and B are angles in standard position. Remember, standard position means the vertex of the angle is at the origin of the Cartesian plane, and the initial side of the angle is on the positive x-axis, such that cosine of A is equal to negative 7/25, with the condition that A is between pi and 3 pi over 2, and sine of angle B is equal to negative 3/5, with B between 3 pi over 2 and 2 pi. All of this is the given information. this is what they want you to find. 3 different parts for this problem. Find sine of A minus B, tangent of A minus B, and the quadrant of A minus B. All right, everybody, let's find the first thing here. Let me just fix that. Part A, find sine of A minus B. All right, let me change the color here for us. All right, here is part A. Okay, me answering part A. Sine of A minus B. By the difference identity, we know that sine of A minus B means, or E is equivalent to, sine of A times cosine of B minus cosine of A times sine of B. That's the difference identity for sine. Now, let's see. Sine of A is not given. We got to figure out what that is. Cosine of B is not given. We have to figure out what that is. But cosine of A is given. It's negative 7/25 times sine of B, which is given, negative 3/5. All right, perfect. So you can see then the unknowns are sine of A and cosine of B. So my job right now is to use cosine of A to figure out what sine of A is. After that, I need to use sine of B somehow to get me cosine of B. All right, let's start with the first one. Cosine of A, how can I use that to get sine of A? All right, let me move this whole, before I move the screen up, okay, I want you to notice a couple things here. When they say, right here, when they say angle A is between pi and 3 pi over 2, what quadrant is that? If you said quadrant number 3, you are correct. So this is really important when choosing our signs later on. We are saying that angle A is in quadrant 3. All right. What about angle B? They're saying that it's between 3 pi over 2 and 2 pi. So what quadrant does that put angle B in? If you said quadrant 4, good job, you are correct. All right, so remember these two things when we do our work. All right, now let me scoot up a little bit here. All right, very good. So this is what we need to find. We need to find sine of A. Okay, so remember this, that cosine squared of A plus sine squared of A is equal to 1. This is the Pythagorean identity, Now, you can solve for sine of A here. Sine of A is going to be equal to plus or minus the square root of 1 minus cosine squared of A. That was me subtracting cosine squared of A from both sides and then taking the square root of both sides. Now, do you remember where angle A is? If you rewind the video just a little bit, we said angle A is in quadrant 3. Now in quadrant 3, sine is negative. So then I'm going to take the negative root here. Furthermore, cosine of A is given. Cosine of A is negative 7/25. According to the identity here, I need to square that value. All right, now it's just arithmetic. So sine of A is equal to negative. Let's see, this is going to be, the number 1 is the same thing as 625 over 625. That's number 1. Minus, be careful with these signs here. These two negatives right here do not make a positive. Remember, you have to, by the order of operations, square this negative, which becomes a positive. And so it's minus a positive number, all right? So be careful. So this is minus 49 over 625. I hope that you can now see why I chose to write the number 1 as 625 over 625, because I knew that the other fraction was going to have 25 squared or 625 as its denominator. So you see that this is equal to negative square root of 576 over 625. That is to say, sine of A is equal to negative 24 over 25. All right, so what you're going to see me do now is go back up here and plug that value in. Back up here and plug in sine of A, which we just found to be negative 24 over 25. Okay, everybody, I need to find now cosine of B. I'm going to find cosine of B very, very, very similarly to how I found sine of A. All right? So bear with me for a second here. Okay, so I'm going to section this off here just so that we don't get confused. All right, cool. Now, I want us to find sine, or no, we're looking for cosine of B, actually, cosine of B. All right, here we go. Cosine squared of B plus sine squared of B is equal to 1. And these exponents are the number 2 up there, okay? All right, cool. Now, we need to find cosine of B, so that's what I'm going to isolate. Cosine of B is equal to plus or minus the square root of 1 minus sine squared of B. Okay? Now, remember where angle B is? Angle B is in quadrant 4. And in quadrant 4, cosine is positive. So we're going to take the positive root. 1 minus, and then sine of B is given. Sine of B is negative 3/5. Okay? All right, with a little arithmetic, we can find that this is the same thing as 16 over 25. Okay? Which is 4/5. All right, cool. You're going to see me now plug this in up here into my expression, 4/5. All right, guys, to wrap this up, all we got to do is this arithmetic here, and then we're done, all right? Let me see if I can move this up a little bit for us. Okay, now I'm coming down here. Okay, so this work will come down here. All right. So then this is equal to negative 96 over 125 minus 21 over 125. So then the final answer is negative, let's see, 117 over 125. This is sine of A minus B. Sine of A minus B. One thing I want you to notice, this is going to be important in part C, the third part of this problem. Notice that this is a negative value. This is a negative value, all right? Sine of A minus B is negative. All right, cool. Let's move forward. All right, the second thing they wanted you to find is tangent of A minus B. All right, guys, by the difference identity for tangent, this is tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. Okay? Like that. All right, let's see. Now, we know what sine of A is. We know what cosine of A is. We know what sine of B is. And we know what cosine of B is. So let's figure out what tangent of A and tangent of B are. All right, so tangent of A, of course, is sine of A over cosine A. Now, sine of A was derived earlier. If you allow me to scroll down a little bit, sine of A, let's see, is here. Negative 24/25. Cosine of A is given. It's negative 7/25. That's given in the problem. All right. So let me go back up to where we just were. We were about right there. So this is negative 24/25 That's what sine of A is. Cosine of A, again, is given negative 7/25. So tangent of A is equal to a negative divided by a negative, which is a positive, which makes sense because A is in quadrant 3, I believe, which means tangent is positive there. All right? So this turns out to be just 24 over 25 times 25 over 7. I'm not even bothering with those negatives anymore because I know a negative divided by a negative is a positive. Okay, cool. So these 25s are gone. Okay? And so tangent of A is 24/7. I'm going to plug that number into my problem over here. Tangent of A is 24/7. All right, cool. What about tangent of B? Tangent of B is equal to sine of B over cosine of B. Now, sine of B is given, it's negative 3/5. And that's negative 3/5 right there. And cosine of B, we derived it. You can scroll back up if you'd like, but you're going to find that it's positive 4/5. Okay, so doing this arithmetic, tangent of B is equal to a negative number, and it is 3/5 times 5/4. These 5s divide out, leaving you with negative 3/4. So I'm going to take this number and plug it into my expression over here for tangent of B. All right, so 24/7 minus, and we just found this number, tangent of B, to be negative 3/4. Like that. Okay? All right, cool deal, everybody. Let's continue with our expression. And then down here we got 1 plus, and then we have tangent of A times tangent of B. All right, tangent of A is 24/7. Tangent of B is negative 3/4. Cool deal. All we have to do now is simplify this expression, and that'll give us tangent of A minus B. All right, let's continue. So then this is equal to, let's clean this up a little bit, 24/7 plus 3/4 over 1 minus 72 over 28. Cool deal. All right. All right, you're going to see me scroll down a little bit to give us some room here. All right, so then this is equal to, getting common denominators here, I'm going to have to multiply the denominator here by 4, and the numerator, of course, by 4 as well, in order to get a common denominator of 28. For this guy, I'm going to have to multiply the numerator and denominator by 7 in order to get a common denominator of 8. All right, so this will end up giving me 96 over 28. Plus 21 over 28. Again, I multiplied the first fraction in the numerator and denominator by 4. This one I multiplied the numerator and denominator by 7. All right, this denominator here will be 28/28. This is the same number as 1 minus 72/28. I decided to write the number 1 as 28 over 28, just so that I have common denominators that I can now combine these fractions. All right, so then this turns out to be 96 plus 21, which is 117 over 28, divided by 28 minus 72. I believe that is negative 44 over 28. All right, cool. So then this is 117 over 28 times negative 28 over 44. All right. You can see that these divide out, the 28s divide out, leaving you with negative 117 over 44. Cool deal, everybody. This is your final answer. Okay? Tangent of a minus b. All right, cool. This was a fun problem, I think. All right, now listen. We're about done. Tangent of a minus b is negative. All right? So for part C, the last part of this problem, it asks us to find the quadrant of a minus b. Okay, and so this is what we found so far, everybody. In the first part, we found that sine of a minus b is negative. Okay, in the second part, we found that tangent of a minus b is also negative. So then you have to think about what quadrant satisfies both of these conditions. When is sine negative and tangent negative? Sine is negative in quadrants 3 and 4. Tangent is negative in 2 or 4. So then with both of those conditions being met, this has to be quadrant number 4. So quadrant 4 is the answer for part C. We know it is just by looking at the signs of our answers in parts B and A. All right, everybody? Good job on this problem. Excellent. This concludes this section, 5.4, Sum and Difference Identities for Sine and Tangent. Great job. Good luck on the homework section for this, for these types of problems. I'll see you in the next video, which would be 5.5, and that's going to be entitled The Double Angle Identities. All right? I'll see you then.